for giving me. Hello. Hello.
Yes, sir.
Yeah, are you able to hear me well?
Yes, sir.
Yeah. Okay. So I'm just opening these slides. You please wait. Can you just tell me that how many participants are over there? It seems that there are 88 participants. Hello.
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 Sir, you are audible. Yeah. Sir, you are audible.
Yeah, Mr. Desmukh, are you able to hear me well?
Yes, sir. Yes, sir. No problem.
Yeah. Okay, so now our topic is being based on descriptive statistics and inferential statistics. Do you have any idea what is this descriptive and inferential statistics? Do you have any idea? Anybody in the class? That what is this descriptive and inferential statistics? Otherwise, I'll start. I'll share the slides, and you are supposed to tell me that you are able to see it well or not.
Yes, sir.
I'm just sharing it. I'm getting some answers like collection of data organized in a logical fashion. This is what is perfectly fine, that this is collection of data, but our issue is beyond the data collection. Our issue is beyond the data collection means we are not only being bothered for data collection, we are being bothered for the inference we are going to make from the data. Data is hugely large, which is sometimes beyond our control. So what we are trying to do, descriptive statistics is going to define the data. Descriptive statistics, from the name, this is very clear that is going to describe the data, and inferential statistics on the other hand is going to make the inference from the population through a small sample. I mean to say that we are going to take a small sample from the hugely large population, which is this population is sometimes uncountable, most of the times uncountable. I take an example of population. Suppose because my basic scheme is management, so I'm having the tendency of taking the examples from management and which are being relevant for everybody. So I take an example of customer satisfaction. Customer satisfaction is our topic, and I would like to have customer satisfaction for any product. This product may be a colored television, and even company may not be knowing now that if suppose you see that if LG is the company, just for the sake of an example, and they are in the process of knowing the customer satisfaction for, they have launched a new television and they would like to know the customer satisfaction. So what is required over there from the large population? Large population may be the LG color television users since last 20 years and their level of satisfaction. I'm showing the slides. Yes. Yes. Lights are being visible. The screen sharing is paused. That's visible. Hello, slides are visible.
Yes, sir. Yes, sir. Slides are visible.
Yeah. Okay. I was saying something that I was taking an example of customer satisfaction, and I was saying something that our today's discussion is being divided in two parts. First part is descriptive statistics, and second part is inferential statistics. And you are supposed to learn the difference between inferential statistics and descriptive statistics. This chapter number 3 is not being the abrupt start. There may be some chapter number 1, there may be some chapter number 2, but because of the time constraint for today's discussion, I am just taking chapter number 3 directly. Chapter number 3 is the measures of central tendency, and chapter number 4 I am going to take. Chapter number 4 is your measures of dispersion. So we would like to wind up descriptive statistics by taking chapter number 3 and chapter number 4. Chapter number 3 is going to describe the data, in terms of mean, median, mode. And chapter number 4 is going to make the measures of dispersion. Measures of dispersion is the catch of scatteredness of the data. And I'll take few examples, and with the help of the examples, this may be clear to you all. And this is what is chapter number 3 and chapter number 4 are the parts of descriptive statistics, and chapter number the other chapters which I'll be sharing in terms of the chapters are the part of your inferential statistics. So measures of central tendency and this chapter number 3, and I'll take chapter number 4 is the part of descriptive statistics. Descriptive statistics, I mean to say mean, median, mode, and everything is going to describe the data only. By descriptive statistics, we are going to describe the data, and with the help of inferential statistics, we are going to make an inference from the data. So descriptive statistics mainly is being used for describing the data, no inference. So first part, which is descriptive statistics, is being only focused on describing the data, and the concluding part, which is inferential statistics, is making inference from the sample for the large population. Making inference from the sample for the large population. Population is always, most of the times, every time, is uncaterable, is undetectable, is unapproachable. So what we are going to do as the part of inferential statistics, we are going to take a small sample from large population, and that small sample is to be investigated for making inference about the population. When we make inference about the population, we are either 90% confident, 95% confident, or 99% confident. So this inferential statistics is the science of prediction, which we do in the light of complete uncertainty. When there is complete uncertainty about something, you take a sample from the large population, you study the sample statistically. When you study the sample statistically, you learn how to use the sample for making inference about the population. Population, as I've told you earlier, is option left other than taking a sample, a small sample from the large population. Population may be having the, are you able to hear me well? Hello? My voice is clear? Hello? Hello?
Yes, sir.
Yeah, this is clear. My voice is clear or not?
Yes, sir. You're audible.
Yeah. So that is what is we are dealing with inferential statistics. So descriptive statistics is the miniature of inferential statistics. When you are not supposed to make the inference for the population, you use descriptive statistics. Descriptive statistics is nothing but your mean, median, mode, which you may have studied in class 12, which you may have studied in your graduation. I may be able to know that what is your basic qualification. Otherwise, you all are engineers.
I think that like it's from different backgrounds. So I think most of them are engineers, and also some are computer scientists, some are from different fields, some are like university professors. So the uh, participants are a little bit mixed.
Yeah. Okay. Fine. That's fine. So you may be having a fair idea about mathematics and statistics, which we all have studied in class 12, or maybe sometimes the preliminary statistics is being taken in class 10. So now you see that we take the similar kind of statistics further. When we take the similar kind of statistics further, because now the statistics is being taken in the graduation or post-graduation level courses. So what we study over there? We study the refined techniques of making inference for the population through the small sample. And this is the complete science. This is the complete science, and we all will have to learn this science, because whatever may be the issue, whatever may be the research, let it be the medical research, let it be the engineering research. In your engineering research, sometimes you'll be finding a probability value. So the concept of probability, whether it is being taken in the classes of statistics, masters in statistics, or maybe in mathematics, or maybe in management, or maybe in engineering, or maybe in MTech, the concept of probability would never be changing. So what we slightly change the application of probability. We slightly change the application of probability. In what context we change? In the context of the problem, which is the understanding, but the basic concept of probability would never be changing. We all know that P plus Q is equal to 1. Happening or not happening is equal to 1. In the classes of business management, I'll take my understanding further for solving the business problems. Same statistics would be used for solving the medical problems. Same statistics would be used for solving the engineering problems. So in research, we are having the problems. We solve the problems using statistics. So there's a myth being available that statistics is being related to mean, median, mode, and all that. This is not true at all. We are taking this class, or the class is being based on the discussion of statistics. But in the light of this discussion of statistics, we are actually opening the dimensions of research. So actually, what are we going to discuss today is being linked with research and is the part of research methodology. In my institute, we are having two subjects: research methodology for engineering and research methodology for management. Both the subjects are conceptually different, but what we do, we use statistics in both the subjects, making the application different for engineering, making the application different for management. I'm reiterating, making the application different, but I mean to say that in no case there would be the conceptual difference between engineering and management, or medical science, or social science, or maybe any other science. You are going to apply it throughout. The probability concept is going to apply it throughout, but that would be applied in terms of your problem. So when I take the mean value, I mean to say that there may not be any difference in the classes of engineering, management, medical, and social sciences. Mean is mean. Mean of what is important. Mean of what would be different in the management classes. Mean of what would be different in the engineering classes. And that mean would always be having the same conceptual meaning. I again reiterate. So our topic is descriptive statistics and inferential statistics. Descriptive statistics is the initial part of inferential statistics, and is not the separation between descriptive and inferential statistics. And is your topic, and your topic is descriptive statistics and inferential statistics, and is the addition side. This is N means addition. I am trying to understand that how to compute the descriptive statistics. I repeat, descriptive statistics, mean, median, mean, and all that. And I would be using the descriptive statistics for the sample to make the inference about the population. Population is 30 crore. Example, population is 30 crore pertaining to any problem, and my sample is sometimes 3,000 only. So you may be able to ask a question that why would you be taking a sample of 3,000 only? So I'm not saying that you should be taking a sample of some proportion from the
Excuse me, sir.
population. Yeah, hello.
Sir, slides are not moving.
Moving. I'll move the slide. I'll move the slides. Right. Now this is moving. Central tendency is being visible.
Yes, sir.
Yes.
Yes, sir.
Central tendency. So what
Hello,
I
sir.
mean-
Sir,
Huh.
sir, there is a small rectangular over the slide. Black
Huh?
color. There is a small black color rectangle is available over the slide.
Over this slide, something.
Yeah,
like-
some-
yeah, I'm able to see how to remove it. And there's some black color over here. That's it. Huh? This is- Yeah. Yeah. It- Now this is clear.
Yes, sir.
Okay.
Yes, sir.
So I mean to say that central tendency is the single centric value, and you are going to. Huh? नहीं, वो कहाँ गया? No, it's okay. Now slides are clear.
Yes,
Clearly
sir.
visible.
Yes, sir.
Yeah. Okay, the central tendency is the single value, is the centric value of the data. We would like to compute the centric value, right? So now if you see that you are 82 people in the class maybe some variety of people are over there. I wish to know something about the class. So if what would I be saying that that what is the mean value? By the mean value, for the sake of an example, I'll say that mean value of country A is 20,000. Mean value of country B is 40,000. So I'll be able to know that on the basis of the mean value that what kind of data is being available over there and what kind of the centric value is being available over there. But mean is having some problems. Mean is always being fluctuated by the. I'll focus on mean. So all these are the measures of central tendency. There's arithmetic mean, there's geometric mean, there's harmonic mean, and these are the positional averages: median, mode, quartiles, deciles, and percentiles. Right? We'll take some example in the practical session to compute all these. And this is the part of descriptive statistics only. We must not be forgetting that we are dealing with descriptive statistics only. We are not dealing with inferential statistics, and inferential statistics is not being started yet. So this is what is descriptive statistics. All these are the tools by which we compute descriptive statistics. So you may be able to ask a question that why are you taking up all these 8-9 tools or maybe more than that? So I will be able to say that arithmetic mean is having some drawbacks. Then we computed geometric mean, then harmonic mean, then median, mode, and all that. All these are the positional averages. So every point of every tool of central tendency is having some drawbacks. So in the light of the drawbacks, we take another measure of central tendency. So you may be familiar with such kind of terms, but we are not familiar that why we are moving from mean to median, median to mode, mode to quartiles, quartiles to deciles, then deciles to percentiles. We'll have to understand that mean is always having the tendency of getting fluctuated by the presence of extreme observations in the data distribution. I mean to say that there are three numbers. For the sake of your understanding, I'm saying that these numbers are 0.01, second number is 2, and third number is 20,000. Mean would always be equal to 20,000 something. If I take these three numbers, 0.01 plus 2 plus 20,000 divided by 3, I'll get the number around 20,000. So this 20,000, which is actually a mean of these three numbers, is a representative of the last number 20,000, but is never the representative of the first two numbers. So you'll have to understand that mean is having the tendency of getting fluctuated by the presence of extreme observations. Just say 20,000 is the extreme observation in the data distribution. So mean would not be giving you the clear picture of centric value. Then I'll go to median. Median tells, I'll show you the mean. Arithmetic mean is sum of all the observations divided by number of observations. This is just the example only. Prashant will tell you with one click after finishing the class, with one click in Excel and Minitab, my PhD student will tell you, Prashant Pandey, his name is Prashant Pandey, he will tell you that how to use softwares for computing mean, median, mode or central or for the central tendency. So now this is the mean. Another way of computing the mean when frequency distribution is being available. All these examples are very childish examples, so no need to discuss all such kind of things. With one click will be, I'm just scrolling down these slides so that you would be able to connect with the concept. But ultimately we are in the process of computing the mean only. When weights are being available, that sometimes potato may not be, potato is important, but ice cream may not be important. So when you compute, when you provide weights to different commodities like ice cream and potato, rice, wheat are important. So you compute this weighted arithmetic mean. When weights are being assigned to the importance of the commodity, weighted arithmetic mean is being computed. Then geometric mean. Geometric mean, when we are having the percentage increase and decrease. Percentage increase and decrease means I'm saying that the price is increased by 2% in 2017, 3% in 2018, 3% in 2019, 5% in 2020. When such kind of percentage increase or decrease is there, we never consider arithmetic mean. In such cases, we consider geometric mean. Geometric mean is this is the formula of geometric mean, but I'm just trying to show you that, I'm just trying to tell you that geometric mean is being considered when we are having the percentage increase or decrease. Now, this is the example of geometric mean. Geometric mean, when for a factory in 5 years, such is the growth, 7%, 8%, 4%, 6%, and 10%. Arithmetic mean, the evidence is being available, is not going to give you the right answer. Otherwise, I would have added all these and I would have divided this by 5. So in the simpler understanding, I would have added 7 plus 8 plus 4 plus 6, and I would have divided that by 10. Am I right or not? I would have divided that by 5. So I would have got arithmetic mean of that, but that mean would have not been accurate. So when we will be having the percentage increase and decrease, instead of taking the arithmetic mean, we take the geometric mean. Geometric mean, arithmetic mean, and all such kind of means would just be computed by just one click. So when you would be having the practical session, you would be able to get the practical way of doing that with the help of one click. So you'll get the dimensions of that. Then harmonic mean, as I've taken the example of that, when the data is being highly uncertain, means some numbers are very small, some numbers are very big. In such a case, when we'll have to compute the mean like this example, you see the data like this, how much is being variation being available in the data. This starting from 2, 1.5 like that. Now the smallest numbers are like 0.095 and all that. And I'll have to take the mean. I've told you earlier that arithmetic mean is having the problem. If I take the mean, I would never be all the means are equal. Whatever would be the arithmetic mean, that would be close to 2000, or that would be close to 2250. These two are the extreme observations in the data distribution. But that would never be the representative of 2, 1.5, 3, 10 and all that. So that is the problem of arithmetic mean. In the light of that problem of the arithmetic mean, we discuss, we take harmonic mean into our consideration. Now, these are the examples. Prashant would explain the examples to you, how to use Excel for this. And we are going to take 3 softwares, Excel is the general software. You all know about Excel. Minitab is the statistical software. We'll use Minitab also. And then we'll use the sophisticated software SPSS to understand the concept of descriptive statistics and inferential statistics. Now we'll move to positional averages. When we move to positional averages, I'll take, now you may be able to ask a question that why you are moving to median when you said that we are having the mean being available as the measure of the central tendency. Where's the need to have median? You may be able to ask a question or not, or you wish to ask any question, please ask a question pertaining to the initial discussion. Wish to ask any question? Any question? Anybody in the class? Vikas Kumar, Abhilasha, anybody? Priyanka? Deepa?
Yes, sir.
Yeah. Okay. No questions? You wish to ask any question, you can ask question in between. Median is the middle number of the data distribution. Why middle number of the data distribution? Can you tell me where's the need to have median? I told you earlier that mean is the middle value. Have I told you this or not? Anybody in the class?
Yes, sir.
I told you that mean is the middle value, right? Now I'm saying that median is the middle value. Mean is the middle value, but mean is having the tendency of ignoring the median. You know, median is what? Median is the middle number. When you would arrange the data in ascending or descending order, median is going to tell you the story of middle number. So why does the need to have the middle number? Because mean is being fluctuated by the presence of extreme observations. So what we would do, we'll take the median. So what would I do? I'll arrange the data on ascending or descending order, and I'll compute the median. Then obviously, you would be able to ask a question that when you are saying that median is the middle value, this is what is the median computation? Just for the sake of discussion only. Otherwise, median is the story of the middle number in the data distribution. These are the examples of median. Now we are having the mode. Now you may be able, because this is the online class, so I'm very sure that you people are listening this very carefully, and I'm very sure about that. So now, otherwise, I would have asked the question in the general class that when I'm saying mean is the beginning, median is the middle story, mean, median, mode, and all that is very common term. You all say that when we talk about statistics, you all say that this is all about mean, median, and mode. Statistics means what? In the general understanding, we all say this is mean, median, mode, nothing. But this is not mean, median, mode. Mean, median, mode is the symbolic indication of statistics. I'm trying to raise a point where we'll have to understand mean is over there, median is over there. Mean is having the problem that mean is being influenced by the presence of extreme observations. Median is having the problem that median tells you the story of the middle number only. Middle number only. Suppose 100 are the numbers in the data distribution. So median is 50. You do not know the left side of 50. You do not know the right side of the 50. You know only 50. Left side is not known. Right side is not known. Middle point is being known. So we are going to move to mode. Mode is going to tell you the maximum frequency of occurrence in the data distribution. So distribution may be having a single mode. A distribution may be having many modes, or it may be having two modes. So when a single mode is over there, distribution is being referred to as unimodal distribution. When two modes are over there, distribution is referred to have bimodal distribution. When multiple modes are over there, distribution is referred to as multimodal distribution. I'll take the example of mode over here. You see the last point, bulleted point over here. For example, a series is like this. This is arranged in the order of the magnitude, and observation 3 has the maximum frequency, which is 4. So observation 3 is the mode in the data distribution. So I mean to say that mode is the maximum frequency of occurrence in the data distribution. Variety of ways are over there to compute the mode, but we people are not being bothered for such kind of mathematical computations, because now we are in the process of making inference from the data, and this descriptive statistics is the beginning only. So we'll move further. We'll move further to discuss some other points of discussion. What are these other points of discussion? This is what is the distribution, data distribution. Whatever is being visible in your slide, symmetrical, for a symmetrical distribution, mean, median, mode coincide are equal. For negatively skewed distribution, mean, median, modes are having the positions which are being displayed by the figure B, and for the positively skewed distribution, mean, median, mode are having the positions which is being displayed by figure 3.23c. Now you see, now there's a problem that I'm saying that mean is going to tell you the centric value, but is being influenced by the extreme observations. Median is going to tell you the story of the middle number only, but the first half and the later half is not being known to us. Mode is going to tell you the story of the maximum occurrence in the data distribution. Other than that, so now you see that from the median, I'll move to quartiles. Median is going to tell you the story of the 50th percentage of data distribution. When 100 are the items being available in the data distribution, median is going to tell you the 50th percentage. So, but when I'm describing the 50th percentage, 0 to 49 and 51 to 100 is not being known to me. I do not know what is 0 to 49. I do not know what is 51 to 100. So in such a case, I divide the data distribution into quartiles. Quartile is 25th percentage of the data distribution, which is being referred to as the lower quartile. Then 50th percentage of the data distribution, which is the median. Then 75th percentage of the data distribution, which is the higher quartile, which is the upper quartile. So now what am I doing? Instead of making the median as the middle value, I am dividing the data into 25 percentage first quartile, 50th percentage median, 75th percentage, that is third quartile. So now data is being, now I'm saying that your data is being the lowest number, first quartile, median, third quartile, and the highest number. We are trying to understand the data. We are in the process of understanding the data, which is why we are using this chapter as descriptive statistics. We have not yet started inferential statistics. So quartiles can be computed very easily by the help of SPSS. Now quartiles are going to divide the data into 4 parts: 0, 25, 50, 75, and 100. Deciles are going to divide the data into 10 parts. Similarly, percentiles are going to divide the data into 100 parts. Because I am in the process of understanding the data, which is why I am dividing the data, and Prashant is going to tell you in the classes, in the practical classes, how to SPSS. One software is being available, which would be giving you the options of placing the numbers over there. So you may be able to place the numbers over there, and that is going to divide the data into equal parts, like 100 and 200, like that. So now, after the introduction of softwares, everything has become very convenient and very easy. You wish to ask any question? And this example is being available just for the sake of example only. And all these solved examples, Excel. Now you see that these are the softwares. I'll not be discussing softwares in this class. In the concluding session from 5 to 6:30, Prashant would be discussing the software applications. Now, this is what is the first part of the descriptive statistics. You wish to ask any question, you can ask the question. You wish to ask any question? Or I'll move to the next point, next chapter. And this is the concluding chapter for your descriptive statistics. Okay, I'll press the F5 key in this slide. I'm opening the new slide. Measures. New share. Okay. New chapter. New share. Now this is visible. Chapter number 4. Chapter number 4 is visible. Somebody is saying that the similar concept is being used in SQL, and probably you are referring to statistical quality control. SQL is what? Now slides are being visible or not? Yes, structured query language. Yes. So I'm taking the new chapter. I'm taking the new chapter because the topic which was being given to me, it was the descriptive statistics and inferential statistics. I'm just trying to do justice to these two topics in the light of the limited time being available for taking up the topics. Otherwise, these are the separate chapters, and will take maybe 1.5 hours for taking up each and every chapter. So measures of dispersion is the next point of discussion. From the previous discussion, I'll continue. Now in the previous chapter, we discussed mean, median, mode, and percentile, quartile, decile, and all these, dividing the data in some parts. But I'm just raising a question that I'm just giving you the number. Let that be the any number. Let that be the any number. Scatteredness of the data distribution means let that be the mean, let that be anything, but scatteredness, suppose mean income of a state is very high. Mean income of a state is very high because incidentally in that state there are 100 billionaires. Because of the presence of the 100 billionaires on the state population is 20 lakh. In the 20 lakh population, we are in the process of computing the average income. Average income is very high because 100 billionaires are there in the state. Because of the presence of 100 billionaires in the state, average income is high. And that is not the right picture because remaining 20 lakh people, barring these 100 people, are not having that kind of income. So on the basis of the 100 billionaires, we are making the average income overstatement of the average income. So that is the problem because when mean alone, median alone, mode alone would not be able to describe the data distribution completely. So we need to catch the scatteredness of the data distribution. When we are in the process of catching the scatteredness of the data distribution, I'll use measures of dispersion. Measures of dispersion is just another mean of understanding the scatteredness of the dispersion. The scatteredness around the mean is the standard deviation. Lastly, we'll be concluding up to standard deviation. Now you may be able to see in the screen that three are the curves. So curve A, curve B, curve C, these three are different curves or not? These three are different or not? Or these three are same? Anybody can answer in the class? Anybody can drop the message? Yes, these are different, right? But you know, for these different curves, mean is same. Mean is same, which is being depicted, which is being denoted by mu in the horizontal line. So when curves are different, but mean is same for both the curves. So that means in terms of scattered, your curve C is highly scattered, curve A is peaked, and curve B is in between. But in no case, these three are similar curves. But mean is indicating this similar distribution. On the basis of the mean, I would say that these three curves are same. And as a matter of common observation, we all would be able to understand that mean is not same. You wish to have a break of 5 minutes? Anybody? You want a break? No. So I'll continue up to 4:30. No, somebody is saying okay, somebody is saying continue and all that. What is what? So I'll continue. I'll take another half an hour to introduce this inferential statistics, and then Prashant will take up the practical classes. So now these three are three curves, and mean is the mean is same for all these, but curves are different. I'll move to the next slide. Now we are in the process of starting the measures of dispersion. Measures of dispersions are absolute or relative. Absolute is presented in the same unit, and relative measure is presented in two different units. Units means rupees and dollar. Rupees and dollar. I'm saying that 1 rupee, $1, 1 yen, like that. So units are different, units are same. Four are the measures of dispersion. These are range, interquartile range or quartile deviation, mean deviation or standard deviation. Standard deviation is the finest way of scattering the scatteredness of the distribution. And standard deviation, you know, we have been using standard deviation from last maybe 180 years as the measure of dispersion, standard deviation. Range is the story of, in the previous discussion, we discussed that we are in the process of describing the data. In the process of describing the data, we described lowest number. Then we said first quartile has 25th percentage of the data distribution. Then we took 50th percentage as the median. Then we took 75th percentage as the third quartile. Then we took 100 percentage of the data distribution as the largest number of the data distribution. Range is going to tell you the story of the largest minus smallest. Largest, the extreme large on the right side to extreme mini in the left side, and the difference of both these is being referred to as range. And coefficient of range is the largest minus smallest divided by largest plus smallest. This is what is the coefficient of range. This is the small example of range. And with one click, as I've told you earlier, that this, when we will summarize the chapter, there would be one example, and that example would be taken by the one click in the Excel, in the SPSS, and in the Minitab, and that would be referred to as the summary statistics. Summary statistics is nothing but your title of today's discussion, descriptive statistics. So one click is going to give you the result, but for the interpretation of that one click result, you'll have to take all these into your understanding. And then we are having the interquartile range and quartile deviation. So quartile deviation is the third quartile minus first quartile divided by 2. So average of third quartile minus first quartile divided by 2, and coefficient of quartile deviation is being given by that formula which is being displayed over there. Now this is what is the 5-number summary. 5-number summary is the smallest first quartile, second quartile, and third quartile, and the largest interquartile range is there. Q3 minus Q1. Range is L minus S. What we are going to do? We are going to understand the data. In terms of understanding the data distribution, we are actually trying to examine the data. What kind of data we are?
Sorry to disturb you, sir. Sir, could you make it as in full screen?
Yeah. What should I be doing? I'll try to do
It is
that.
in full screen. It's not in a full screen mode for now.
Now this is,
Yes, it's visible. And your voice is also a little bit low.
my voice is low.
Yes, sir. Yes, sir.
Okay. How to enhance the voice that I don't get?
Might be you can use your microphone. Means if you are using the headphone.
No. Right now I'm in the office, so I do not have that. I'll try to speak loud. Then it would be probably clear. My voice will be clear to you. Now the slides are being visible.
Yes, sir. Slides are perfect. Yes. Now it's in a full mode. Yes.
Yeah. Okay. Now my voice may be clear, more clear.
Yes, little bit it's louder compared to the previous.
Yeah, okay.
Yes.
Okay. So actually mean deviation is the deviation from the mean. You may be able to notice, I'll tell you some concept of the mean deviation, and you may be able to ask a question that what is the difference between mean deviation and standard deviation. You may have noticed that so earlier range was the story of the largest number and the smallest number. And after that, quartile deviation was the story of the difference between the third quartile and the first quartile. So we'll have to have some deviation being available. So why not to have average deviation of every item of the data distribution from the mean? And that is what is being given over there in terms of mean absolute deviation. So now what is happening when I'll take because mean is the middle value. So when I'll take the mean and when I'll take the difference of every number from the mean, there may be the possibility that the numerator of the formula would be 0. There may be the possibility. Why there is the possibility? Because mean itself is the middle value, and I am taking the deviation from every observation of the data distribution from the middle value. So there may be the possibility that middle value, the numerator value may be equal to 0. In order to avoid that numerator 0, we place a modular sign over there. When we place a modular sign over there, we tend to ignore the important algebraic plus or minus signs. So that makes this mean deviation most unadoptable. Likewise, mean deviation, we may be having the median deviation. We may be having the mode deviation like that. But that is the deviation from the middle value. Most unadoptable in terms of placing the modular sign over there. By placing the modular sign, we tend to ignore the important algebraic plus or minus signs. So mean deviation is being discarded from the wide use. Wide use means what we use. You all may have heard of. This is clear. My voice is clear. आवाज आ रही है? Yes. Okay. So now I'll move to next slide. Now, this is what is the mean deviation. I was telling you earlier that there is the possibility only, and I mean to say that there is the high possibility that this 215 sometimes would be equal to 0, because you are taking a mean is the middle value, you are taking deviation from the middle value, and when you will add all the deviation without taking the modulus sign, there may be the possibility that this would be equal to 0. So numerator is going to be 0. When numerator is going to be 0, mean deviation is 0, and the purpose of taking the mean deviation in terms of understanding the scatteredness of the data would completely be diminished. So in such a case, what would we be doing? We would not be taking the modulus of the quantity in terms of standard deviation. I'll square the quantity xi minus x bar, and I'll place that under the square root. Squaring the quantity and placing that under the square root is not denying the important, not ignoring the important plus or minus sign. Sometimes plus or minus are very important in the data distribution. We cannot ignore that. So now we are moving to the concept of standard deviation. In standard deviation, I am simply placing the similar xi minus x bar. Xi is the individual observations, x bar is the mean, and then squaring that and placing that under the square root, and the denominator is n minus 1. Why this denominator is n minus 1? I will not opening the discussion at this point of time. This n minus 1 is being referred to as degrees of freedom. My freedom is very much important in statistics, because statistics believes in freedom. The freedom of selection of sample from the population. If there is no freedom of selection of sample from the population, I would not be able to apply statistics, because my choice is not being not being biased. My choice is random. I will randomly pick samples from the hugely large population. I'll randomly be picking. In no way I'll be attaching my bias in the sample selection. So I'm saying that our journey started from mean. Our journey is covering mean. Our journey of scatteredness, our journey of descriptive statistics is slightly going to end over here in terms of discussion of standard deviation, which is nothing but mean deviation, because of the problems of ignoring the important plus or minus sign, squaring the quantity, placing it under the square root, summing it and dividing it by n minus 1, not n. This is n minus 1. I'll discuss it laterly, that what is this degrees of freedom. Just by taking the sample from the population, suppose in a population there are 25 elements, up to 24th selection, my choice is free. But when the 25th element was being left in the sample, and I was not having the choice, 25th was left and 25th was to be selected in the sample. So up to 24th, choice was being free, but for the 25th, choice is being restricted because I have taken a sample. So sample itself is restricting me, and which is why my denominator is n minus 1. My freedom is restricted by one element, and when my freedom is being restricted by one element, this is n minus 1. So which is why this is n minus 1. This is not n. Otherwise, it would have been n. But because you see in the formula, I'm saying that sample standard deviation Probably you are understanding that by taking the sample only, I am restricting my freedom. And when I'm restricting my freedom, that is to be depicted in the formula, and that is being clearly depicted in the formula. This n minus 1 choking, restricting my freedom by one element. That one element is obviously being generated by taking a sample. I'll have to take a sample. When I am taking a sample, my freedom is restricted by one element. And then variance is the square of that quantity, the upper quantity. So standard deviation is that the formula is being given over there. Standard deviation is nothing but deviation from the mean, adding it. Deviation from the mean, adding it and dividing it by the number of observations. So right now we are in the beginning of statistics where we are having the freedom being restricted by the one element only. And when we'll move to advanced statistics, my freedom would ultimately be restricted to some 25 or 26 elements. मेरा कहने का मतलब ये है, what I mean to say that when I'll move to inferential statistics in advanced stages, my problem would become so complicated. This time n minus 1 right now for the beginners would become n minus 25, n minus 28 like that. So our problem is so complicated. Our research problem means our research problems are so complicated. I'll have to take the understanding up to that extent where my freedom is being restricted up to 28 elements. So whatever is being n minus 1 over here would become 28 at that point of time. Now coefficient of variation is this. There's the formula of coefficient of variation, because when I'll have to compare the two series, one series is in dollars and second series is in rupees, and I'll have to consider it. I'll have to compare it. When I'll be comparing, I'll be using coefficient of variation instead of standard deviation and all. One example is being given on coefficient of variation. Now this is what is the empirical rule, and in every subject this empirical rule is having different dimensions. You see that the middle quantity is the mean. This quantity is mu plus sigma, mean plus standard deviation. Right side, mean plus 2 standard deviation. Rightmost, mean plus 3 standard deviation. Leftmost, mean minus 3 standard deviation. Upper side, 99.7% of the items in the data set are going to fall in between mean plus minus 3 sigma standard deviation limits. Mean plus minus 3 standard deviation limits, and this is what is the empirical rule of statistics. Now this is what is the measures of shape. The left A, figure number A is the left skewed distribution, figure number B is the right skewed distribution, and figure number C is the symmetrical distribution. Please remember that this symmetrical distribution is the start of inferential statistics. We have partially finished descriptive statistics. Descriptive statistics, measures of central tendency and measures of dispersion. All these, what we discussed in terms starting from mean to standard deviation, are the descriptive statistics, describing the data but not making inference from the data. Symmetrical distribution is the foundation of making inference from the data. Now coefficient of skewness is the indication that if coefficient of skewness is positive, our distribution is right skewed. If coefficient of skewness is negative, our distribution would be left skewed. I'm saying that if coefficient of skewness is plus 0.73, that means this is right skewed distribution. When I'm saying that coefficient of skewness is minus 0.73, that means this is the left skewed distribution. Now kurtosis means this is steepness of the distribution. Your leptokurtic distribution is A, platokurtic distribution is B, and in between these two mesocortic distribution is being depicted by figure number C. 5 number summary is that we have discussed earlier. And this is what is the box and whisker plot. Box and whisker plot is going to tell you the story of the 5 numbers. No, somebody is asking about root mean square and all that. This is what is the conceptual thing. I am discussing the standard deviation right now. Standard deviation we have discussed earlier, and now you see that you say that my data is being what item would be the outlier in my data. So Prashant would tell you in the next class, in the practical class, that with the help of the Minitab software, we'll place the data distribution over there, and that is going to tell me I'll answer few questions. I'm noticing the questions that suspected outlier. Now you see that this is what is the smallest value, first quartile, median, third quartile, largest value. This box and whisker plot. Box and whisker plot for what? It's to notice the outlier in the data distribution. Inner fence formula is being given, is being applied in both the ends, left hand and right hand. Outer fence formula is being given. Whatever is being available in the inner fence and the outer fence in between, that is suspected outlier, and outlier is above that. So the point which is being, now you see that when we'll take the practical example, I'll take an example where we'll take some numbers and I'll place a hypothetical number over there. When I'll place a hypothetical number, like in the example, SPSA, sorry, Minitab is going to make that clear outlier in the figure. Clear outlier in the figure means by box and whisker plot, you detect outliers from the figure, from the data distribution. This is box and whisker plot, which Prashant would explain you in the next class. Now we are in the process of knowing the measures of association. Measures of association is the coefficient of correlation. Coefficient of correlation will again be taking that in detail in the descriptive in the inferential statistics class. When R is equal to 0, no correlation. When R is equal to +1, perfect positive correlation. When R is equal to -1, this is perfect negative correlation. So this is just an example of correlation. This is one example is like this. You read the example. This is the simple example of computing the correlation between advertisement and sales. Is there any correlation between, my question is there any correlation between advertisement and sales? I'll use the formula. I'll not have to use the formula and I'll not have to compute such heavy thing. Rather, with one click, I'll be able to get it in Excel. But otherwise, my correlation coefficient is being computed as -0.51. Minus 5.51 is the indication when I am spending in the advertisement, my sales is having the deterioration, not enhancement. My sales is having the deterioration by that 0.51 proportion. I'm just trying to coin the foundation of inferential statistics just over here. If this data is the sampled data, I will have to make this sampled data information for the population. So now, for making that inference for the population, I will use this inferential statistics, my descriptive statistics ends over here. So same example I'll take in the inferential statistics. Here my question is compute the correlation between sales and advertisement. in the inferential statistics topic, my question would be slightly different. I would be asking the question that this sampled information is being valid for population or not. In the inferential statistics discussion, my understanding would be based on sampled information, and that sampled information is true for population or not, and if true, up to what extent. These are the 5 examples of strong negative, strong positive, moderate positive, and no correlation. When no correlation, R is equal to 0, you would never be able to apply any relationship based measurement like regression. Regression is the relationship based measurement between X and Y. So when R is equal to 0, when R is very low, like 0.1, 0.2, regression cannot be applied. Relationship techniques cannot be applied. So we'll take all these in detail in the classes of descriptive statistics. One practical example is also being given over here that would also be taken in detail in the classes of descriptive statistics. I wish to now you wish to ask anything, you please ask. Anything you wish to ask, you please ask. We use box and whisker plot for one purpose. We are supposed to detect the outliers from the data distribution. Whatever is being available in the outer fences of the box and whisker plot are the outliers in the data distribution. These outliers are to be removed from the data distribution in order to make scientific predictions. And second question is, this is SPSS. SPSS is software package for social sciences. This is just a software. This book is being, from where we are taking the slides. This book is going to take, this book has taken 3 softwares. Excel, you know, Minitab is another software of statistics, and SPSS is the advanced software of statistics. This is SPSS. Y is not over there. SPSS. And in the next class, Prashant is going to take up the details of SPSS. SPSS is being mainly used for the variety of tools and techniques of statistics, and we use SPSS for techniques like regression and such kind of techniques, right? Now you see that your inferential statistics is entirely different from that. For inferential statistics, we set the hypothesis. I'll just be I'll open one chapter number 10 directly. You allow me to open chapter number 10 directly. When you open chapter number 10 directly, I'll show you something for inferential statistics. Now this is being visible, slide number 10, sorry, chapter number 10. Yes. Okay, so this is what is the because we are having only 15 minutes remaining. So I'll just tell you the statistical inference and the story of statistical inference. Now you see that we are moving, we are in the process of understanding. We took chapter 3 and chapter 4. Now this is chapter 10. Some of the chapters which were being conceptual in nature are being missing over here. But the you know that statistical inference is the discussion, half of the discussion point today. But statistical inference is the entire branch available in statistics. But otherwise, I'll tell you the story of statistical inference. I'll first make the slide through. Now slideshow is being clear. Visible. Okay. Thank you. So now I'll move further. So statistical hypothesis is the basic part of inferential statistics. In statistics, you make hypothesis. Hypothesis is the unproven statement, and with the help of the sampled information, you apply some of the tools and techniques of statistics, and you make the hypothesis. And then applying some concepts of statistics, you either accept the hypothesis or you reject the hypothesis. 7 are the steps in setting the hypothesis. Null hypothesis is the status quo. Alternative hypothesis is challenging the status quo. Null hypothesis is suppose I am saying that 5 years ago I have computed the average income of a particular state, particular town, and the average income of the town at that point of time. Acha. This book material is being available. I'll provide. You want to have the slides for this? Okay, so I'll provide the slides to coordinator of the program. Right, so coordinator of the program would be providing you all these slides. Okay. So null hypothesis is the status quo. Alternative hypothesis is the challenging the status quo is the alternative hypothesis. Now you will have to determine the appropriate statistical test. What tests are being available? What tests are supposed to be applied? Then you'll have to decide about the level of significance, whether this is 1%, 5%, 10%. Level of significance, I'll just be telling you in brief. This is just a brief that there is always a possibility that I would commit a mistake in making the inference. My mistake commitment possibility is 1%, 5%, or 10%. There is no chance that I would never be committing a mistake. When I take a sample from the population, with this sample, I'll make inference about the population. Possibility is over there, and we believe that there's a possibility. This possibility is 1%, 5%, and 10%. We apply some of the techniques, and we will make the result applicable in 1%, 5%, and 10%. When 1% is the possibility of committing a mistake, my confidence is 99%. When 5% is the possibility of committing a mistake, my confidence is 95%. When 10% is the possibility of committing a mistake, my confidence is 90%. So in statistics, in making the inference, I am 99% confident. I am not 100% confident. What confidence and what mistake? Mistakes are, I'll tell you these mistakes. So when my sample would fall in the shaded region, I'll reject the null hypothesis and I'll accept the alternative hypothesis. When my sample statistic, जो sample से compute होगा, that would fall in between the non-shaded region, I'll accept the null hypothesis and I'll reject the alternative hypothesis. The step number 5 is collecting the sample data, analyzing the data using the test like Z, T, F, and chi-square. These are the statistical tests we use. Then arriving at a statistical conclusion. Our conclusions are statistical in nature. Ultimately, implications are different from statistics. And this is what is the hypothesis test. In hypothesis, we apply two-tailed test of hypothesis. Null hypothesis is this. Alternative is having not equal to sign. When not equal to sign would be over there, I place the rejection region on both the tails of the normal curve. ये two-tailed test है. जब both the test of the normal curve में rejection region होगा, then that would be a two-tailed test. In as compared to this, there would be a one-tailed test that is being referred to as the right-tailed test. and left tail test. When critical region would be on the left tail, that would be a left tail test. When critical region would be on the right tail, that would be a right tail test. And what I was telling you earlier that I'm 90% confident, 95% confident, 99% confident. That means what mistake I may commit. I'm saying that I may commit a mistake. What mistake I may commit? This is type 1 error. This is also been decided in advance. I may either commit type 1 error or I may commit type 2 error. Type 1 error, rejecting a true null hypothesis. Null hypothesis is true and I'm rejecting it. And type 2 error, accepting a false null hypothesis. So when null hypothesis is false and I am accepting it. So two are the possibilities of making the correct decision and two are the possibilities of committing an error. So when we commit an error, my confidence level when it would be 90%, that means 10% is the possibility that I may commit a mistake. What mistake? Type 1 error. Rejecting a true null hypothesis. 95%. 5% is the possibility that I may commit a mistake. What mistake? Type 1 error. Rejecting a true null hypothesis. 99%. Again, 1% is the possibility that I may commit a mistake. What mistake? Rejecting a true null hypothesis. And these are the examples. Prashant would take these examples in detail and would tell you about the concluding remarks of inferential statistics. You wish to ask any question, you may be able to ask a question. These examples, what are being given over there, Prashant would take these examples. You wish to ask any question, the forum is being open for asking the questions. Any question?
Sir, what is the significance of standard deviation?
जी? Hello?
Sir,
हाँ
am I audible?
हाँ हाँ बताइए.
Yeah. What is the significance of standard deviation? What can we infer by knowing the standard deviation?
Yeah, very good question. Standard deviation is the deviation from the mean. When you catch the scatteredness of the data distribution, you'll have to have the standard deviation in your hand. Standard deviation is going to catch, otherwise all the tools which we have discussed like mean, median and all these, mode and percentile, quartile, all these are going to decide the position or the centric value of the data distribution. Standard deviation is the advanced version of range. Range is going to tell you the story of last two. Quartile deviation is Q3 minus Q1, 75 minus 21, like that. Standard deviation is the standard tool of making the average deviation. When I'm saying that standard deviation is 100 for a data distribution and 100 standard deviation is 200 for a data distribution. That means the data distribution which is having 200 standard deviation is more scattered as compared to 100 standard deviation data. Is this clear?
Yes, sir. Yes, sir.
Yes, and anything else you wish to ask, or around 5, Prashant would start the class and whatever is being visible over there, all these examples, Prashant would take all these examples in detail. Or you wish to ask any question, please ask the question. Practical Prashant will take, PhD student from here would take the practical session of the classes. Anything else you wish to ask? Please ask. Maybe in 2-3 minutes I will be able to wind up. A lot is over there. This is descriptive statistics and inferential statistics specifically. Inferential statistics is like an ocean, is the deep sea. Means lot of topics are over there, and all these topics are interconnected. So if you are going to take up the topic, we are going to pick up the topic from abruptly, randomly from the book. So sometimes understanding would be There for a uniform distribution, there would be the different formula of standard deviation is not is not related with uniform distribution. Standard deviation calculation formula is being available in uniform distribution. When I'll send you the slides, this is the part of chapter number 6. Uniform distribution is uniformly distributed. Uniformly, this is not like the opposite U, which is the normal distribution. This is uniformly distributed, 1,000 like that. So there's the formula of standard deviation in the uniform distribution, right? Okay, so now I'm winding up the class, and around 5 o'clock, Prashant would start the class, and Prashant would take you to the application of descriptive statistics and inferential statistics, right? So, should I stop the class? Thank you for attending class. Thank you very much. Please, I'm leaving now.